Alright, I wanted to review this problem because I remember on the first test we had a little bit of an issue with it. So, we have two spheres of equal mass and they're released from rest. So, when B reaches the 20-meter mark, its speed is 5 meters per second. And when A reaches the 10-meter mark, its speed is 6 meters per second. So, what we want to do is determine the ratio of these two energies. So, let's be clear. We want the gravitational energy ratio. So EG of the second ball is going to be M times M of B times G times H of B, whatever that is. And now we look that up. So they have equal mass, so that's going to be 1 times 10. And B is at 20, so that gives us a gravitational energy of 200 joules. All I'm doing is I'm looking at the height, and I'm just using the MGH formula to calculate it. And then for A, same thing, M of A times G times H of A. Quick question, why don't I write G of B here and G of A here? Well, it's because it's the same G, because remember, it's really convenient to try to label every variable with a subscript when you're just trying to solve a problem. Let's be clear, G here is 10 meters per second squared as it is here. So this is going to be 1 times 10, and A is going to be at 10. So that's 100 joules of gravitational energy. So when we do this fraction that they want, that's going to be 200 divided by 100, and that's going to be a ratio of 2 to 1. Now we want the ratio of the heights. So let's be clear. This is actually a conservation of energy issue. So let's be clear. When we're released at a height, that means this initial V is 0 here. And here, we're released from rest and we fall. So let's be clear. B here has a total energy that is both gravitational and kinetic. And the same is true for A. So again, we know this because it's moving, so that means we've got EK. And there's a height, which means we've got EG. So the idea here is we're released from rest at some unknown height. So we've got some initial B energy. And the same is going to be true for A. Same idea is we're going to have some kind of EG for A as well. So let's put all this together. I'm going to have MGH of A equal to 1/2 MV of A squared plus M times G, and A ended up at 10. So let's get A's energy. We're going to end up getting 1 times 10 times HA equals 1/2 times 1. And V of A, we're told, is 6 meters per second, so we'll square that, plus 1 times 10 times 10. So what I'm going to end up getting is here, when I simplify, 10 HA equals 18 plus 100. Or in other words, HA equals 10 HA equals 118. And when we finally simplify, HA is going to equal 11.8 meters. Now we're going to need to do a similar calculation for B. I'll just choose a different color. So for B, we're going to have MGH of B equal to 1/2 MV of B squared plus MG, and B was at 20. So we have 1 times 10, which is 10 HB equal to 1/2 times 1. Now B was moving at 10 meters per second. Sorry, 5 meters per second plus 1 times 10, and B's height was 20. So we're going to end up getting that 10 HB ends up being, when we simplify it all out, 212.5 meters. So HB ends up being 21.25 meters. So we have 11.8 versus 21.25. So that ratio is going to end up being, and I'll actually do this up here, we're going to end up getting 21.25 divided by 11.8. And when I actually simplify that ratio, it's going to end up being 1.8. Awesome. So that's the answer. Now here. We're going to go ahead and do 6 through 8 a little bit carefully. So let's see. When we start at position A, let's see, do we start at rest? So we're going to assume it starts at rest because they don't give us a speed. So we've got all EG here. And then what's going to happen? At B, it's got some EG, but mostly EK. At C, it's going to have all kinetic energy. And at D, it looks like it's come to rest, so it's going to have a combination of gravitational and elastic energy. Right? So we want to know how many joules of energy the car has at point B. So we have EG at A, and I'm going to set that equal to the second bar graph at position B, which is EK plus EG at B. Keeping this in mind, we're going to end up getting here I'm sorry, I'm going to need to make a correction on this. You know what? We're going to skip questions 6 through 8 on this. I don't like the way these numbers look. So we're going to skip number 7. And we're going to skip number 8 on this. And I'm actually going to send a text out to everybody on this one. We're going to take up this problem next time on your second practice test just to be safe.